Assalamualaikum and a very good day I bid to all. My name is Amirul Amin bin Nur Helmi from Group 4 and our group will be presenting about material use in corrosive environment. Corrosion is a major concern in harsh environment for any kind of material being used in the industry. It can cause equipment failure, safety hazard, and significant financial loss. Choosing the right material can prevent corrosion and save costs in the long run. Corrosion is the degradation of material caused by chemical reaction with the environment. It can occur due to moisture, salt, acid, and other factors. When selecting material for use in corrosive environment, choosing material that can withstand harsh conditions while maintaining their structural integrity is crucial. Factors that need to consider include chemical resistance, strength, durability, and the cost of the material. The commercially used material that is being used in industry include stainless steel, aluminum, and non-metallic, such as fiberglass. Next, the material that we choose for our topic will be the fiberglass reinforced plastic, FRP. FRP is a composite material made up of several different components. The first component will be the polymer matrix, which is the base material that provides the shape and structure of the FRP. The polymer matrix typically made of materials such as epoxy, polyester, and vinyl ester. Next will be the reinforcement, which is a fibrous material that is added to the polymer matrix to increase its strength and durability. For example, like glass fiber, carbon fiber, and aramid fiber. The third component of the FRP will be the additive and fillers, which is added to the polymer matrix to modify its properties. For example, like calcium carbonate. And last one will be the surface finish, which is the additive or modifier which is used to enhance the properties of the FRP. For example, like pigment, UV stabilizer, and fire retardant. When these components are combined, they create a material that is strong, lightweight, and the most important thing will be the corrosion resistant. FRP is known for durability and cost effectiveness, making it popular choice in the industry. Rather than the commercially used material like aluminum, stainless steel, and others.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Taufik Berwadi. Today I will explain regarding the detail on physical properties of the chosen material, which is fiberglass reinforced polymer (FRP). Several physical properties has been identified through research that have been conducted. First and foremost, the density of FRP is relatively low compared to conventional steel, which is about one quarter the weight of conventional steel. Other than lightweight characteristic, it comes with high strength and high durability. This characteristic makes it easy to handle and suitable for heavy industry application such as civil structure. The third physical property that has been identified is corrosion resistant. FRP is renowned for its corrosion resistant characteristic because it is made of fiber and polymer matrix that is resistant to chemical reaction with corrosive compound. Other than that, FRP also possesses a low coefficient of thermal expansion, which means it will not influence by temperature changes, such as weather. Last but not least, this characteristic is quite related to the previous properties of FRP. FRP is resistant to UV radiation. This is because FRP composites are made of polymer matrix that includes additive for protection against the damaging effect of UV radiation.
Assalamualaikum warahmatullahi wabarakatuh. My name is Haikal Muhammad. Now I will present to you the mechanical properties of the fiberglass reinforced plastic. So for the first, tensile strength. It has a high tensile strength with value range from 300 megapascal until 1200 megapascal. This depends on the specific composition and fiber orientation. So for the compressive strength, is typically in range of 200 megapascal until 1000 megapascal, against depending on the specific composition and manufacturing process. So for the shear strength, it's usually in range of 60 megapascal until 150 megapascal. So for the impact properties, FRP has excellent impact resistance, capable of absorbing high energy impact without fracturing. The impact strength can vary depending on the specific composition and fiber orientation. For the stiffness properties, young modulus of FRP is known for its high stiffness, with young modulus typically range from 15 gigapascal to 40 gigapascal, providing rigidity to composite structure. So for the pop- for the fatigue process, FRP has a good fatigue resistance, allowing it to withstand cyclic loading without significant degradation in performance. The fatigue strength depends on the specific composition and manufacturing process. So for the lastly is thermal properties. The coefficient of thermal expansion for the FRP is relatively low compared to metal, which help minimize thermal deformation. So for the heat resistant, FRP has a good heat resistance, retaining its mechanical properties at elevated temperature, typically up to 100 until 150 degree, depending on the resin metric used. So next is the microstructure of the SRP. The microstructure of the SRP is contain matrix, which is typically a polymer resin such as a polyester and vinyl or epoxy, which provides the bulk of material's properties and hold the glass fiber in place. So the second one is the glass fiber that serve as the reinforcement and are typically embedded in the matrix. They provide strength, stiffness, and the impact resistance to the composite. So for the third one is the fiber rotation, which is it used for the matrix that's effect of mechanical properties of FRP. Common fiber orientation include the unidirectional, woven, or the randomly dispersed fiber. So for the lastly is the interfacial bonding, which is its content and quality of the bond between the glass fiber and the matrix is critical for the optimal mechanical performance. A strong interfacial bond enhances load transfer and its overall mechanical strength. And it's important to take note that the specific mechanical properties and microstructure of FRP can vary depending on the manufacturing process, resin formulation, and fiber content. So that's all from me.
Next, for the fabrication of FRP. Fiberglass reinforced plastic (FRP) is typically fabricated using a process called layup or hand layup. Other than that, methods of FRP fabrication also include compression molding, filament winding, and pultrusion, which are typically used for more complex shapes or high volume production. Step of layup process. First, a mold is created that corresponds to the desired shape of the FRP part. Next, layers of fiberglass cloth or mat are cut to the appropriate size and laid out over the mold. The fiberglass layer are then saturated with a liquid resin, which is typically a two-part mixture of polyester or epoxy resin and a hardener. The resin-soaked fiberglass layers are then carefully placed into the mold, starting from the center and working outwards. The process is repeated until the desired thickness and strength of the part is achieved. The part is then left to cure, which typically takes several hours or overnight, depending on the types of resin used and the ambient temperature. Once cured, the part is removed from the mold and any excess materials is trimmed away. The next one is application of FRP. The first one is in construction. FRP is often used in construction for applications such as structural support, bridges, staircases, and building facades. The next one is transportation. FRP is used in transportation applications such as aircraft components, boats, and vehicle body panels. The third one is chemical processing. FRP is resistant to a wide range of chemicals, making it ideal for use in chemical processing plants for storage tank, piping systems, and scrubbers. The next one is water and wastewater treatment. FRP is commonly used for water and wastewater treatment applications such as tank, piping, and covers for treatment facilities. And the last one is in electrical and electronic. FRP is an excellent electrical insulator, making it useful for electrical and electronic applications such as electrical enclosures, transformers, and circuit boards.
So for the conclusion, the application of fiberglass reinforced polymer in corrosive environment can be beneficial because of materials corrosion resistant properties. FRP composite can be used in a broad range of corrosive environments, including chemical factories, water treatment facilities, maritime environments, and offshore oil and gas platforms. In such circumstances, FRP can be utilized to replace conventional materials that are more vulnerable to corrosion, such as steel or concrete. However, when selecting FRP composites for a certain application, it is crucial to consider elements such as type of environment, the rate of exposure to corrosive chemical, and the design requirement.